Alright, hello. So, today we're going to be going over the basics of three-dimensional objects, starting with prisms and the idea of volume, surface area, and lateral surface area. So, just like when we did two-dimensional shapes and we said area was the amount of 1 by 1 squares that fit in an object, volume is the three-dimensional equivalent. So that is the amount of 1 by 1 by 1 blocks that fit inside of a solid. And with this idea, we can derive almost all the formulas we need. Then we have something called surface area, which you could think of as the amount of paint it would take to cover the object. It's the two-dimensional area of the sum of the surfaces of your three-dimensional object. Lateral surface area is the surface area minus the two bases, or the area of all the faces that are not the bases of an object. On it sounds a little confusing, but it's really not too hard. So, in our object here, we have a prism. This prism has lengths AB equal to 3. So AB over here is 3. BC equal to 4, and AE equivalent to 5. Part A asks us, what is BF? Well, BF is, we notice it's this line that goes from the one base, A, B, C, D, all the way down to the other base, E, F, G, H. So it would be the same thing as the line AE, which is 5. Then it asks us what EH is. EH is the same line as AD, and AD is the same line as BC, so therefore EH is 4. And that is all of part A. Now part B, volume. If we can remember that volume is the equivalent of the amount of 1 by 1 by 1 cubes that fill up this object, well then we can think of it really as a simple multiplication problem. How many 1 by 1 by 1 cubes would it take to fill up this container? Well, we would need rows of 3 going in the direction of AB. And then we would need a stack of 5 with the height. But we would also need to cover BC's distance, that horizontal distance. So in total, your answer would be 5 times 3 times 4. Which is, well, 5 times 4 is 20, and 20 times 3 is 60. And that would give us our total volume. Alright, now what is the surface area? Well, the surface area is equivalent to the added areas, or the sum of the areas of the faces of this object. So for example, if I wanted to find the area of BCGF, that rectangle, it would be length times width, or 4 times 5. But if I notice that is the same area as ADHE, because they have the same dimensions. So instead of just doing 4 times 5, I'm going to do 2 times 4 times 5. And I'm going to add that with, well, if I look at the area of ABFE, that would be 3 times 5. But I also notice that has the same area as DCGH. So again, instead of just doing 5 times 3, I'm going to do 2 times 5 times 3. And then finally add it with my two bases, A, B, C, D, which has the same area as E, F, G, H. So that's 2 times 3 times 4. Well, that would become 2 times 4 times 5 is 20, plus 2 times 5 times 3, 15, plus 2 times 3 times 4, which is 12. Well, 2 times 20 is 40, plus 2 times 15 is 30, plus 2 times 12 is 24. 40 and 30 is 70, plus 24, well, 70 plus 20 is 90, plus 4, 94. That gets us our surface area. Okay, now on part D, find AC. Now AC is a line going from, well, obviously A to C. Now, this, in my opinion, is easier to think about if we look at it as a two-dimensional rectangle instead of trying to examine the entire 3D object. So if I just draw out this rectangle like this, and I'm going to say that this is A, D, C, B, and AB is 3, BC is 4, and what I'm trying to find is AC. Well, this makes it fairly easy because now it's just a problem involving Pythagorean theorem, where I'm trying to find my hypotenuse. So I can do that by doing 3 squared plus 4 squared equals AC squared. 3 squared is 9, plus 4 squared 16 is AC squared. And if just doing some basic simplification, I will find out that AC is equivalent to 5. So that is my value for AC. Alright, now it asks us what kind of triangle is ACG. So A to C to G would be a triangle going like this. So what kind of triangle is that? Well, since this is, it's taking place on a prism where all the sides are 90-degree angles, or all the vertices I should say, that means this vertice right here is also 90 degrees. So that means that ACG is a right angle, or a right triangle. And if I'm trying to find AG, it's probably worth it to do as we did before and just write out that triangle. So I have this right triangle that somewhat looks like this, where this point here is A, then we have C, and then we have G. And this is our right angle. AC we just found out is 5. CG is also going to be 5 because it's the same length as AE. If I want to find AG, well, it's the same thing, Pythagorean theorem. And we will eventually get that this is 5 times the square root of 2. just by doing the Pythagorean theorem. And that gets us all of our answers.